ladies and gentlemen, you have made it to the last video of Chapter 11. We skipped 11.7, and now we're going to talk about Section 11.8, which is on solving rational equations. Like this, where you've got rational expressions within an equation, and we're going to try to figure out what the value of x is. Now, before we do a rational equation like this, I want you to look at a really simple one, and that would be, what if I said, solve this? Gee, I wonder what x must be. How would I solve? Oh, wait. If x over 10 equals 3 over 10, and you have a common denominator, the solution is kind of... So if that ever happens, your answer is kind of a freebie, right? Now, we don't have that situation over here. We've got unlike denominators, but we've got another weapon in our tool belt here, and that is... Weapon in our tool belt? Who puts a weapon in a tool belt? A tool in our tool belt. Stay away from weapons. Increase the peace. All right. Our tool belt of mathematical capabilities, this is what we call a proportional relationship, and I can do what's called cross products or cross multiplication. Meaning 2 times x should equal 4 times x plus 1. And boom. Now I don't really have a rational equation anymore. Now I just have a regular old flat one-story equation here, and I've just got to solve it. So I have 2x equals 4x plus 4, and I'm going to take away 4x from both sides. And this is like a 6th grade equation or 7th grade equation at the most, right? And we're going to divide by -2 and just finish the process and get... Okay, the only thing I want you to be warned about on this one is check your solutions. And why is that important? Because whenever we have rational expressions, there are the possibility of extraneous solutions. Right? Meaning, if we had done all this work and got x equals -1, x can't equal -1. Or if we had done all this work and gotten x equals 0, nope, x can't equal 0. So watch out for extraneous solutions. In this case, is x equals -2 extraneous? No, x can equal -2. That's perfectly legal. And so we are done with this problem. But you do want to make sure that you check whenever necessary. Okay, now let's step it up to a more challenging problem. 4 minus p over p minus 1 equals 2 over p minus 1. Now, we don't have exactly a common denominator here. We have 2 pieces that have a common denominator and 1 piece that doesn't have a common denominator. So guess what I'm going to have to do to this? I'm going to have to make this piece have a common denominator with those pieces. So I'm going to have to take this and multiply it by p minus 1 over p minus 1, which is really just multiplying it by 1, so it's legal, right? And so I'm now going to have 4p minus 1 over p minus 1 minus p over p minus 1 equals 2 over p minus 1. Okay, so now at this point, can I expand this earlier analogy and say, what if my problem was b over 10 plus 1 over 10 equals 3 over 10? Since they're all tenths, can't I just basically say b plus 1 equals 3? Yeah. b equals 2, doesn't it? 2 tenths plus 1 tenth equals 3 tenths. So can I do the same thing here? If this over p minus 1 minus this over p minus 1 equals this over p minus 1, then shouldn't this minus this equal that? Yes. So I'm going to rewrite that, distributed, minus p equals 2. And I'm not even going to bother with the denominators at this point because they're kind of irrelevant. Hopefully that makes sense. So all I got to do now is just finish the problem. 4p minus 1p is 3p p. If it's all right with you, I'll just go ahead and add 4 to this side, and I'm going to say p equals 2 is my solution. Is that one okay? Can p equal 2? Yeah, 2 is fine. And that is my solution. Now, you should also check this by plugging it back in and seeing if it works. So let's just do that real quick. So I'll rewrite the original equation, but I'm going to put a 2 everywhere I see a p. So it's going to be 4 minus 2 over 2 minus 1 equals 2 over 2 minus 1. So what's 2 over 2 minus 1? Well, 2 minus 1 is 1, and 2 over 1 is 2. So I'm going to get 4 minus 2 equals 2 over 1, which is 2. Does that work? Yes. So now I know, double check, that that answer is totally 100% the correct solution to this rational equation. Okay, so we're going to try to get common denominators for all of the pieces, unless it's just proportional, ratio equals ratio, then you can cross multiply. This one we couldn't cross multiply because there was more than just a fraction and a fraction. There was multiple expressions here. So let's see about a real nice one here where we get to look at 3 different things. We can't cross multiply because it's not a proportional situation here. And we're going to have to try to make all of this have a common denominator. One note that I want you to see right off the bat is x squared minus 1 is x plus 1 times x minus 1. If you remember, this is a difference of squares, so we can factor that. So these two denominators are actually similar, right? I don't need to multiply this expression by anything. I just need to multiply this one by x plus 1 over x plus 1. Now they match. And then what do I have to multiply this by? The whole thing. X plus 1, x minus 1. X plus 1, x minus 1. Okay, so now, do all 3 expressions have a common denominator? X plus 1, x minus 1, x plus 1, x minus 1, x plus 1, x minus 1. And we said that when they all have a common denominator, you can scratch the denominator and make it a 1-story equation instead of a 2-story equation. So now I'm going to write this as a 1-story equation. X plus 3 minus, I've got a FOIL. No, not FOIL, just distribute, right? 2x times x is 2x squared. 2x times 1 is 2x. Notice I put that in parentheses because this minus means I'm going to have to minus that and minus that. So I got to be careful here. And then what do I have over here? 1 times x plus 1 times x minus 1. So I've got to FOIL that. Oh, but wait, that was this, wasn't it? X plus 1 times, oh, FOIL it to check, but it's x squared minus 1. Feel free to pause the video if you need to take a minute to make sure you know how I came up with what I just came up with. Basically, I took this, and I took this. I kept the equal sign right where it was. Now I've just got to do a bunch of algebra to try to solve all of this. So I'm just going to say x plus 3 minus 2x squared minus 2x minus x squared plus 1 equals 0. Why did I move this over here and this over here? Because whenever I see x squareds, it makes me think quadratic. Whenever I think quadratic, I like to have that equals 0 over there. Now let's simplify it. I got negative 2x squared minus x squared is negative 3x squared. I got 1x minus 2x is negative 1x. And then I've got 3 plus 1 is 4. I've got to solve this thing, if I'm going to have a good chance at knowing what x equals. So how do you solve a quadratic equation like this? You could try to factor it. That 3 is going to cause us some problems, but it's doable. Or we could use our good friend, the quadratic formula. Remember that guy? Okay, so what's negative b? That's going to be negative negative 1, which is 1, plus or minus b squared, negative 1 times negative 1 is 1, minus 4 times a, which is negative 3, times c, which is 4. All of that over 2a, that's 2 times negative 3. Whew, okay, so minus 4 times, okay, so that's plus 12 times 4 is plus 48. 1 plus 48 is 49, yay! That's square rootable. So this is really 1 plus 7 over negative 6, or 1 minus 7 over negative 6. So I'm going to get x equals 1 plus 7 is 8, 8 over negative 6. How about we reduce that to 4 over 3, and it was negative, sorry, that's negative 4/3, or negative 6 over negative 6, which is 1. So those are my two solutions, but let's go back to the original problem. Can x equal negative 4/3? I think so. Can x equal 1? No, 1 minus 1, that would make this 2x over 0. Impossible! So that's an extraneous solution. This is the real solution, and boy, that problem had a lot of steps in it. We had to persevere, but that's okay. We did it, and we got a solution. And you can check that solution by plugging it back in to the original equation if you want to. I want to show you something else, though. Let's say we had taken this original equation and let's say we had realized that this was going to be our common denominator, right? X squared minus 1 is our common denominator. So what if I multiplied everything just by that? Watch what would happen. And you might be thinking, don't you have to multiply the denominators also? Well, are you allowed to multiply everything in an equation by the same thing? Yeah, and that's what I did. So this is okay. This is legal. Watch what's going to happen here. Some matching and subtracting. This together matches that. So we have x plus 3. The x minus 1 scratches with the x minus 1. So we're going to have minus 2x times x plus 1 equals that, which is really that, and basically this would have gotten you here without having to go through piece by piece. Do you have to do it this way? No, it's totally optional. You don't have to do it this way. You don't have to do it that way. It's just two different ways to get to the same solution for the same problem. Now, a lot of the problems that you're going to do for this assignment are going to be on the simpler side, like this and this, but you do want to be able to handle the challenging ones like this. So hopefully this makes sense. Again, like I always say, feel free to pause this video, rewind it, rewatch it, take it at your own pace. If you have questions, write them down, let me know, talk to me. I'm happy to help. But hopefully that gave you a good idea about the culmination of Chapter 8, solving rational equations. And we are now done with Chapter 8 and ready to move on. Thanks for watching. Thanks for listening. I will see you next time.